Hello, everyone. Welcome. Welcome to our next session within the MEV Hackathon. Today will be another amazing workshop from our Flashbots partners. They are our educational partners within this hackathon. Welcome back. We're happy to have you. Little recap on the hackathon. We're in week 2 now. Things are coming up quickly. I will send out a updated email to everybody recapping this week, as well as it's still possible to register for the hack if you'd like. I will post those links here in the chat later. Welcome, everyone. Hello. How are things going? I see people are already active in the chat. Today will be a session from Hasu with Flashbots Strategy. We're going to go more in depth. If you have any questions within the session, please put them in chat. We will kind of answer them at the end. So without further ado, we'll pass it over to our great speaker for today. Hasu, you want to take things over for us?
Yeah, hey, Steve, thanks for the introduction. I have a little presentation prepared. It's not very long, so it's just a couple of slides, some predictions on where I think the MEV space is going, and some things that are, that will sort of occupy us for the next couple of years. And the way that we can do this is, so I'm going to just say my prediction and then a couple of bullet points on each of them. And then if anyone has any questions or comments, then we can discuss these before we move on to the next prediction. And also at the end, if you think that I missed any predictions, then we can also talk about those and see what you guys think the MEV space is going to do in the future. So quick slide about me. I lead strategy at Flashbots. I started this year. So it's still relatively recent. I'm also strategic advisor at Lido. So Flashbots and Lido are actually pretty similar. Both work at basically at sort of the block building layer of Ethereum, right? And so it's actually a big overlap. The kind of things that I think about in both places. And yeah, I mean, I've been thinking about MEV and block space markets and transaction fee mechanisms in the context of Ethereum and previously Bitcoin now for a couple of years. So it was very natural for me to eventually, say, end up wanting to contribute to how some of these markets are built and see if I can make a positive impact here. Okay, and so without further ado, my first prediction is in the next year, we will see the first layer 1 or layer 2 MEV mitigation techniques in the wild. And why is this interesting? So, I mean, for a while, we have been waiting for these and sort of we have been theorizing about what they do, and both in terms of protecting users from MEV, which I would say is kind of a primary effect of these, but then also what second order effects they will create for the blockchains that use them. And I think two are especially interesting to talk about. So first come, first serve, or receive order fairness by another name. This is a technique that, for example, Arbitrum is, to my knowledge, committed to using, and they are working on sort of decentralizing their sequencing and going to a first come, first serve kind of system. And so myself, many others have been theorizing that first come, first serve, it does a good job of protecting users from front running, for example, under normal conditions, but it creates a lot of second order effects for the blockchain that may be undesirable. Why? Because if there's a certain, if sort of 100 utility can be made from getting a certain transaction mined, and you have different parties competing to get this transaction mined because 100 utility is a lot, then they will basically spend up to 100 utility optimizing on latency to be the first to make this transaction. And what this means in a lot of cases is massive spam on that blockchain that that has this technique. And so we have sort of seen glimpses of that. We have seen glimpses of that on chains like Ethereum. So not many people know this. Ethereum had sort of an element of first come, first serve as well in the past, where the sort of the GEF client was using the first transaction that it saw in order to tie break between different transactions that it was putting at the same position in its sort of local block building process. And so the organization that I work with, Flashbots, we built the Flashbots auction that eventually decoupled. It decoupled the preferred placement in the block specified by a searcher from the price that the transaction paid, and so it really sort of took this kind of latency war out of the mempool, leading to a lot less spam. So we saw glimpses of kind of what first come first serve does to a public blockchain, but we've never really seen it like on a big scale. And so I think it will be very interesting to see what happens. Another thing that kind of first come first serve does, and this is kind of the end state of all of these systems, is co-location. And so when the first person who gets a transaction mined gets the reward, then this position, sort of this fastest possible position or connection to the block producer, is very valuable. And that's why all major exchanges sell these so-called co-location rights to trading firms. And these trading firms have a big advantage over, I mean, basically it's impossible to compete if you don't buy this kind of co-location service from the exchange, where they put, your server rack into their own exchange, and there's sort of all kinds of standardized rules for, the exact distance to their clearing servers and so on. So if we end up in a world with first come, first serve, then latency will matter a lot more. And this is a prediction that we will talk about later. So the second interesting MEV mitigation technique is threshold encryption. And how threshold encryption works is basically that people post a transaction that is encrypted with some public key. And the private key to decrypt this transaction is held by a committee, typically of validators, but it can be other parties as well. And so the key idea here is that the block builders, they see the transaction, but they don't see the content of the transaction. And they have to include it and commit to an ordering without knowing what's in it. And so they cannot interact with the transaction in any way that could be harmful for the user. So a few things on threshold encryption. And for one, they tend to add a lot of latency because usually between the commit step and the reveal step, you tend to have at least a couple blocks. They tend to be more expensive, and they tend to have weaker they tend to make stronger security assumptions about the blockchain that they operate on, because they tend to be vulnerable to collusion between these different validators. So where a public blockchain like Ethereum today in proof of work, it makes the relatively weak assumption that like around like 40 to 50% of miners are on it, that like that like 50 to 60% of miners are rational, which is sort of a weaker assumption than honesty. And that's under these conditions, then the blockchain basically works as promised to the users. Whereas if you have threshold encryption, then typically what you get is that you need a lot more. You need to make a much bigger actual honesty assumption and not just the rationality assumption about the participants in the system. And so, I mean, this is a lot of words for saying they are much more vulnerable to collusion. And so, yeah, this is something that we will also be interested in seeing. Like once these systems are actually out, I think if we've learned anything from the MEV space is that really any small edge that can be pushed will be pushed. So if these systems have an attack surface then there's so much money at stake, and people in the MEV space are so creative and crafty. They will find a way, in order to break these mechanisms and try to extract any money that they can. Okay, so Suigeo asks, so if the block data is encrypted and the block builder can't see them, how do they actually publish the transactions? So I can't speak to the actual details. I think I can recommend you to Google basically something like, for example, shutterized beacon chain would be the name of one proposal that does this. But more typically, they are also just called commit reveal schemes. So I think on Ethereum, it's not necessary basically to publish the block content of the transaction. So you can like a transaction can basically just be a placeholder, and then the actual content of the transaction can be revealed later. I think that should be fine. Another question: what do you think of self-slashing to extract MEV? So I don't know about self-slashing. Maybe you can sort of restate the question or explain what that would be. Or do you basically mean validators equivocating on a block and accepting a slashing in order to extract MEV? Yeah, okay. So the penalties for slashing tend to be pretty big. I mean, the situation where basically you want to redo a lot of a block that you previously mined yourself, I think should be pretty rare. So more likely is you would sort of reorganize a block made by another proposer, right? It's sort of way more common that somebody else made the block and you want to steal the MEV. So in that case, you wouldn't even get slashed because you don't equivocate. So you get only slashed if you sign two blocks or you propose or attest to two blocks at the same height. And so you wouldn't even need to do this. And so, yeah, your question generally points at these so-called, reorg attacks or this kind of thing. And and I think there's a good reason why. So I think there's a good reason why we don't really see them at scale, is what I should say. And that's because they tend to be zero-sum games between miners or validators. And so if you do them, then really somebody else can do them as well. So it's basically a winning strategy as long as you're the only person doing it. But once somebody like other miners do it to you, then it's really bad for you. And then everybody wishes, that nobody was doing it. And that's so really it's sort of better for all validators and miners if they don't start doing it. So it's basically an inferior equilibrium. And that's why I think we haven't really seen it happening, because it's very, very kind of short-term motivated, and long-term it'll almost always backfire on you. So it will be very interesting to see, for example, once there is no more long-term. So for example, let's say like a day between the end of proof of work mining, whether miners will become more adversarial towards other miners because they have no, they have sort of no tit for tat kind of behavior to fear at this point, right? Because they know in like a couple hours, the proof of work mining is going to stop. So I think that this would be very interesting. And the second point I have on this is that there has been a paper just I think a week or two ago by a researcher from Cornell, I believe. And what they argued is that one mining pool in Ethereum has actually been secretly doing these kind of reorgs. So that's the interesting thing about proof of work, because proof of work sometimes has these natural forks in the chain where a miner could argue that they were building on a previous block because they were building on on block A because block B hadn't been propagated to them yet, and so they have this kind of plausible deniability. So I would you can maybe Google for that or ask on Twitter, or I can look it up later. But I've been meaning to dig into this paper, and it would be very interesting to see if that researcher is right and it actually happened. Okay, that was a lot of questions. So in the interest of time, we will get into all questions, but I think let's move to the second prediction. So my second prediction is that MEV auctions will become the standard for efficient extraction really on all chains. So by MEV auction, I mean an auction like the one that we have pioneered at Flashbots, where you have a transaction type that's similar, like that's called a bundle or similar, and where sort of the searcher can define, you know, their position in the block relative to some other transaction or just in kind of absolute terms. So they can define the index of the block where they want to be mined, and they can independently of the index bid on the transaction fee. And then what the auctioneer does is they simulate all of the transactions, and they don't include any transactions that are mutually exclusive with other transactions, or that would just revert for other reasons. And so this has really a lot of benefits for everyone involved, but especially for the block producer. And the block producer is typically also in charge of choosing the way that they want to auctioneer their block space. Right? And so the MEV auction maximizes the MEV that is captured by the block producer and not the searcher. And this hence maximizes the revenue for the block producer. And if you don't use an MEV auction, like say you use a normal public auction, like Ethereum has been doing, then what happens is that actually under most circumstances, you maximize the revenue for the searcher, and you create incentives for vertical integration between validators and searchers. And so that's very bad for all validators or searchers who can't participate in this. And so it creates a lot of centralization in the block producer market. And second, for the reasons that we touched on, it minimizes negative externalities for users. So it minimizes sort of reverting transactions from spam and congestion. And so that's very important. And so I think we have now like a lot of other, like all blockchains are basically coming around or will come around to the idea that, you know, MEV that you can't minimize, you have to democratically auction it off. And that's the best thing that you can do. And I want to very clearly sort of delineate this from the idea that MEV is like good or neutral, or that we want to even maximize MEV, because the statement is really like very orthogonal to that, right? So MEV, in most circumstances, it's like money that some person loses. Right? MEV, there's nothing good about MEV. And so we want to minimize MEV as much as we can, but there will always be some MEV that we haven't yet, or that we can't minimize for a variety of reasons. And this MEV is like, you can think, somebody gave like a great example to me the other day, and they were like saying, so MEV is like if somebody drops like $100 or like $1,000 on a congested speedway. And so it causes traffic jams, it causes car accidents, and it causes all of this instability and centralization risks for the base layer. And so that's why it's important that, you know, this MEV is actually scooped up and distributed in a democratic way. So I thought this argument was very convincing. So we want to do both. We want to minimize MEV, and then for the MEV that exists, we want to auction it off, because otherwise we will get into this world of latency wars and spam and congestion that we really are meaning to get away from. Okay. I think there's one interesting question. No, don't worry, I will get to all questions. So in TradFi, market manipulation is illegal. Could MEV be made illegal? So I have some thoughts about that. So for one, like, is it actually market manipulation? I think that's quite debatable, because as a user, your transaction is transparent, right? So you know that your transaction is transparent. You're sending it to a public network. You have no expectation of the transaction actually being private. I think that's very different from you sending your transaction to, you know, like an explicit dark pool of some bank or exchange, and where they explicitly promise you that the transaction is private, will not be front run, and then they front run you anyway. So I think the latter case is clearly illegal, whereas in crypto, I think it's it's not illegal, probably. But that said, like the other question I would raise is even more high level. So like, what do we want? And I think this is like, this question is super relevant right now because of the OFAC sanctions that were put on Tornado Cash the other week, where all of a sudden now people are asking, so do staking pools, mining pools, block builders, and block relays, anyone sort of involved at the block production layer, have to comply with these sanctions? And if yes, what does it mean for Ethereum? And so do you want the block producers of your blockchain to be beholden to some law made by some country? And if yes, like how, I mean, like does this apply to like, I mean, it raises all of these other questions, right? I mean, like, what if sort of law of country A is different from law of country B, and what like, and does it matter like where the origin of the user is, and like all of this, right? And I think it will just greatly reduce the social scalability of the blockchain and make it sort of much less credibly neutral if block producers were actually beholden to all of these complicated regulations. So really, the blockchain works best when the block producer simply sort of maximizes their own revenue. And so that's really important for the incentives of a blockchain to work. So my third point is, this is more, I think this is probably the first one that's a bit more controversial, which is public mempools are going to dry up. What does this mean? So by dry up, I mean there will be less and less of the transactions that will eventually be in the block that gets mined will be seen by all nodes and will have been seen by sort of any miner who just uses the kind of naive native sort of block production algorithm of sort of their local Ethereum consensus layer node. And we have sort of over time, sort of the number of transactions that have been evading the public mempool and going straight to either direct to a miner or to sort of an auction system like Flashbots or Blockstrat or Eden. These have only gone up. Why has that been? It's just because these, you can call them third-party block space auctions or sort of more advanced block space auctions. They can iterate faster and they can sort of create or sort of attract users with much better features than you can get as a user in the public mempool. So if you set your transaction to Flashbots, then you get privacy. You cannot, your transaction cannot be front run. Like it's private until it's included on chain. We simulate your transaction, and so we never include it if it fails, if it conflicts with another transaction. And in theory, there's a huge design space. I mean, just think about the design space for simulation, for example. So if you accidentally make a transaction that would sort of send your money to like a known phishing attacker or otherwise like honeypot, or to a token contract, or I mean, so there are all kinds of ways to lose money on Ethereum, right? Where it's kind of clear that this is not the intention of the user, or you accidentally pay. We saw this today, actually. Someone paid a 50 ETH gas fee on a transaction, which we have to assume was by accident. So because we simulate the transaction, we can actually say, hold up, we don't think this is what you, the user, wanted. So why don't we give you a chance to look at the transaction again and confirm that you really want to do this? And yeah, I mean, these are extremely powerful features, right? I mean, that you can have as a result of this kind of simulation. And account abstraction, another example, right? So many times I have a new account and I receive some tokens, but I don't have any ETH in my account. So I wish I could, for example, pay my transaction fee in USDC or some other token, right? And so what a public mempool or sort of what sort of a private mempool can do is they can allow you to transact in any token. they can just take some of your output token, for example, and pay the transaction fee on your behalf. There's kind of all kinds of things that can be built on top of Ethereum that would make transacting cheaper, faster, more private, and in every way kind of more comfortable for users. But this has one problem, which is that it would make exclusive order flow an increasingly big problem in the block builder market. So exclusive order flow, that is transactions that one builder can use as input to their blocks that other builders can't use as inputs to their blocks. And so you could imagine that one builder has access to 100 transactions, and another builder has only access to 50 transactions. The second builder will always never be able to make a block that is more valuable than the first builder, and they will almost always lose out in the block builder market, right? And what this just leads to is that the first block builder, they will make a lot more money, and the second block builder will go out of business, not just because they make less money, but also because the experience that they can give to their user is decreasing, because their latency is getting worse and worse because they can't get the blocks mined. And so in a world where you have exclusive order flow and block builders compete on exclusive order flow, is a world that gravitates very strongly towards kind of winner take all effect in block building. And that is quite scary. So this is exclusive order flow is a very big risk and very big danger in sort of the MEV space over the next couple of years. Just to give two examples. So MetaMask today, and I don't want to fearmonger against MetaMask. Like MetaMask actually an amazing team and product, and they are very aware of kind of this power that they have over Ethereum. But they control 70% of transactions that are being made on Ethereum. So 70% of transactions on Ethereum originate from MetaMask. MetaMask can control what happens to these transactions between the point where the user signs the transaction and it gets mined in a block. And if MetaMask wanted to make a block builder, then they could immediately monopolize the block builder market in Ethereum. And nobody else would have any chance of ever making a block in Ethereum again, like until sort of users start to migrate away from MetaMask and there's a huge shitstorm against them and the developers react and so on. But I'm talking about more like a creeping kind of effect here. And maybe by some force, it will become socially accepted to use this kind of exclusive order flow, and this will be very dangerous. So there are at least two mitigations that I could think of in preparing for this talk. So the most important is we have a decentralized solution to all of these guarantees for users here that I gave on the previous slide, but that is decentralized, and it's at least Pareto optimal. So Pareto optimal means the decentralized solution is always the same or better as the centralized one. And in that world, I think we can use social conventions against sending order flow to centralized block builders, and hopefully have a world where either a lot of transactions stay in the public mempool or they are in some decentralized solution that has similar guarantees, right? The problem with the public mempool, of course, is that it doesn't have all of these benefits that the private mempool has. And that's why it's important that for anything that is sort of system critical, that a decentralized solution exists that can rival the centralized solution, especially if it's this close to the block construction layer. So any idea, Marcus is asking, any idea what percentage of user originated transactions does MetaMask control? Yes, so the answer is around 70%, I believe. So this is, I think, a statement that was made in the past. It may be like a year old or older, But I don't expect this to have changed very much because we have not actually seen any new wallets coming into Ethereum. So the fifth prediction is that MEV that is caused by users is increasingly returned to users. Usually MEV is the result, or a lot of MEV anyway, is the result of the user having an intent, something that they want to do on the blockchain, let's say in the DeFi ecosystem, on a decentralized exchange or some other place. Usually it's exchange that creates the MEV in the form of backrunning and sandwich attacks. Sometimes it can be an NFT mint or other kind of things that are also subject to front running. But in all of these cases, the user has an intent, and then they make a transaction, and they sort of craft the transaction in a way they determine specific parameters, like when trading on a decentralized exchange. So they choose the exchange that they want to trade on, of course, and like the liquidity pool that they want to trade on. And then they also determine factors like the size of their transaction fee and their slippage tolerance. And what usually happens is that the user has a certain intent, but the transaction that they make, then it sort of has a significant gap or a discrepancy to what their actual intent is. And the difference between this, this actual transaction and the intent of what they want to do, this is basically what ends up being MEV, right? So in the example, let's look at two examples. Let's look at a trade that cannot be sandwich attacked. It doesn't have like a high enough kind of price impact and slippage tolerance, but it's a transaction that sort of trades in, let's say on Uniswap, and it pushes the price somewhat. And this creates an arbitrage opportunity on Binance, where there's a second similarly liquid pool of liquidity. And so what this means is the user created here an arbitrage opportunity. They could have avoided this opportunity if they just split their trade across both venues, Uniswap and Binance, for example, 50-50, and then they would have moved the price maybe equally on both exchanges, leaving no arbitrage for someone else. So I mean, this is kind of a mistake that the user made, right? But if a certain transaction has a certain MEV surface, then it has value to someone. In this case, it has value to someone who is an arbitrageur on Binance. Even more easy, I think, it is to see if we talk about sandwich attacks on Ethereum. Let's say you make a transaction that you are willing to buy, ETH at sort of, I don't know where it trades right now, but let's say like 1,700. Like the price right now is $1,700, but sort of you define your slippage tolerance at like $1,600. And then if somebody uses enough money, then they can push the price of the liquidity pool to actually be $1,600. And then you end up buying the tokens at that price. So they basically buy the tokens. They also buy the token ahead of you. Sorry, in this case, it would have been $1,800 because this is the highest price that you want to buy it. So they end up pushing up the price, and then you trade, and then they end up selling it back at a higher price and make the difference, right? So I mean, in this case, really, sort of, it was your it was you having choosing a liquidity pool where you have too high of a price impact, but also defining a slippage tolerance that was much too high, for example. And so once again, it's like a mistake by the user. I mean, what they really wanted to say maybe is like, I want to be executed at this exact price, and if not, then my transaction should fail, or automatically route my my trade to sort of, the best possible liquidity pools and so on. And so we always know that somebody is willing to pay a higher price for that transaction than somebody else, because that someone can extract MEV from the transaction in a particular way. And the idea would be that we have something that I would call an order flow auction. So an auction system for transactions, something where we sort of put the existing market structure on its head, right? Because right now users are purchasing, making transactions, and they compete with other users for block space. But you can also have it the other way around, where a user makes a transaction, and then if it emits any kind of MEV, then in order to actually get the transaction mined, maybe searchers or block builders have to pay you in order to execute it. Or, maybe you still have to pay, maybe your transaction was not that inefficient, but at least you get your transaction included at the cheapest possible price, because you had actually a competition between these different builders or searchers in order to take your transaction and be allowed to execute it. And whoever does the cheapest, they get the go. So this is, I think we can imagine very different ways by which MEV that's caused by users is going to be returned to users. But we know that there is an economic effect here where sort of users want to transact as cheaply as possible. And so if someone can offer them this, then a lot of users or wallets on their behalf or applications, they will gravitate towards this solution over other solutions, hopefully. And so if we don't want to fall in the trap of the centralized order flow, then we need to hope that this kind of solution will be a decentralized one. I see we are running a bit short on time, so we'll accelerate this a bit so we can definitely go through all the questions. So another big one, the rise of cross-chain MEV. And so cross-chain MEV is basically where you want to make a transaction across at least two different chains, or a chain can also be a centralized exchange. So but anyway, extracting cross-chain MEV is expensive. Why? For one, because you have all kinds of risks that you don't have in a centralized environment, right? So for example, on Ethereum, if you make a transaction, we call this an atomic transaction, then either it gets mined or it doesn't, right? It's not, there is no risk that part of the transaction gets mined, but maybe the other doesn't. And so in the cross-chain world, you do not have the same luxury. So you can make a trade, you can buy ETH on Ethereum, and you can try to sell it on Arbitrum, but there's no guarantee that either both will succeed or both will fail. And so you can be in a situation where one of them succeeds and the other fails. And this is a sort of an additional execution risk. And second, you need all of a sudden you need what we call inventory on both chains. So you cannot take the same ETH that you bought on Ethereum and like rapidly transfer it to Arbitrum. You can try, but it's not going to work within the same block. And so you will be at a disadvantage, the severe disadvantage to anyone who sort of has inventory on all of these blockchains. And so cross-chain MEV will be a big force. And there is a big cost advantage to be gained by someone who has block ordering privileges across several domains. Why? Because they can solve this problem that we talked about. So they can ensure that either both of their transactions succeed or fail together. And usually they can ensure that they succeed. So that is very valuable for them. And so what we need here is to have sort of this block ordering privileges across several domains available for validators on different chains, but without actually having to be the same party, because this would be very bad again for centralization. For example, it would make it completely impossible to be, let's say, a solo staker on Ethereum, because a solo staker on Ethereum would make a lot less money than a bigger staker who's staking on Ethereum and also staking, let's say, on Polygon, right? And so we need a way for these different validators to talk to each other across different chains. So we need sort of a marketplace for cross-chain collusion that will allow these validators to work together and harvest this cross-chain MEV. My seventh thesis is that latency is going to start to matter more. And for one, we talked about the first come, first serve sequencers. So if blockchains deliberately go down this route of kind of latency wars, then the end result will be that searchers, any kind of extractors, are going to compete on latency. So we will see a war for latency, and it will be interesting to see how that will evolve in the crypto space. Latency will also start to matter as sort of Ethereum changes its MEV market structure as part of the merge. So we will now have MEV Boost. And I mean, MEV Boost has many advantages. So it's like a proto version of PBS. It allows even small stakers to participate in the block market and get the most valuable block. But it also adds a lot of latency to the block building process. Why? Because now all of a sudden you have way more parties who need to communicate in the process of block building. And I think it will be interesting to see how this MEV Boost market structure also will evolve. Like what will the role of the relay be, and sort of will this hold, or will we see vertical integration? For example, because block builders or validators start to realize that sort of there is value in latency, right? So they can sort of, if you wait, if you have 1 more second to wait before making your block, then you have a better view, a more accurate view of the state of the world, and you may be able to construct a better block. And in any case, more transactions are always coming in. So you just may be able to make more money if you have, if you sort of can submit your block at a later time, as long as it's still within the 12-second window. And so I think we will see a lot of optimizations around latency. And so we will sort of players who fully embrace latency, and we will see how latency can sort of challenge and break the mental models that we have about kind of MEV market structure at the edges. And so this is my final slide. Well, there's one more, but this is the final thesis. So I think that app level optimization, application level optimizations will drastically lower MEV. And yeah, this is probably controversial with people who are pushing very hard for any kind of solution to MEV at the base layer that then introduces sort of these kind of second order effects. But really, applications, they have a huge incentive to lower the MEV that they emit, but also that the users emit and get exploited for. Why? Because MEV is a hidden transaction fee. So if you get backrun on Uniswap, after Uniswap transaction, you could argue you didn't lose any money, but you lost money in opportunity cost. Why? Because really, maybe your transaction could have been mined $50 cheaper than it actually has. Or if you get sandwiched and you lose $1,000, then I mean it's very clear that your real transaction fee maybe was not $50, but it was actually $1,050. And so I think all of these apps, they have a big incentive to lower the kind of MEV that their applications create. Really, they have, this is like the responsibility often has been pushed on sort of the layer 1 developers and so on. But really, this is the design of the application that causes this, and the design of the application that can solve it as well. And so especially arbitrage is a very low-hanging fruit here. So most MEV, in fact, comes from arbitrage, does not come from sandwiching. And arbitrage, profit that an arbitrageur makes is money that the market maker very, very often, sort of the LP on a decentralized exchange, loses. And we also call this adverse selection cost, because the arbitrageur only trades against them when the arbitrageur has a profitable trade. But when the market maker has a profitable trade, then the arbitrageur doesn't trade. And so you'd always, as a market maker, you're always bleeding money, sort of. We are now seeing increasingly some experimentation. I think just in the last month, I saw 2 different proposals for AMM designs that auction off the right to arbitrage a particular pool. And what this does is it captures the positive, or it retains the positive effect of arbitrage, which is that it keeps the market price in line with the overall market, but it captures much more of sort of the arbitrage profit for the market makers who are losing money from the arbitrage. And so I think I would be very surprised if sort of the available MEV in 1 year from now, or maybe 2 years, won't be drastically lower than it is today. That is sort of emitted by these applications. And so this is kind of my summary. This is the 8 theses again. So the first layer 1 and layer 2 MEV mitigation techniques, we will see them in the wild and see how they fare under adversarial conditions. I think MEV auctions will become the standard for efficient extraction. Public mempools will dry up, and this will cause increasingly the problem of exclusive order flow and eventually builder centralization. Builders and other parties will return MEV to users. We will see more and more cross-chain MEV and attempts to extract it and democratize it. Latency will start to matter more, and applications will on their end also try to lower the MEV that they emit, because it's a hidden transaction fee for their users. Okay, that's my last slide. So now we have time to go through the questions. I will just scroll up and sort of try to answer anything that we haven't touched on before. So how do you apply your poker knowledge at Flashbots? Asks Frank. So I don't know how interesting this this is to most listeners. So yeah, I used to be a professional poker player. I mean, I think the way that I apply it is simply just looking sort of at I mean, a bunch of ways. I mean, for one, I try to think strategically. So I try to think of situations as like strategic situations where you want to first identify what your goal is. And then you want to make a plan how you can reach this goal, and also factor in what the other parties are going to do in the space and what their incentives are. So it's really important to understand the incentives of the different participants. And I think in sort of an immature space like the MEV space, I think this is a good quality to have. I think it's also important to, just, be humble and like admit that you don't know what you don't know, and sort of try to be curious and try to have an open mind for all of these different solutions that are being worked on, because we don't actually, I think we can identify what the big problems are, but for many of them, we don't really know yet what the solutions are. We are kind of all trying to figure it out together. So a question by Jacob. How is Flashbots able to move away from the permission searcher onboarding that it began with using API keys and reputation scores? Just better DOS measures at the relay. So this question is, I think, pointing at like Flashbots has a kind of tiered API. So why does it need this? I mean, because whenever you expose a public endpoint to the world, then you run risk of being DOS'd. And this is very bad for your service, especially if it's a service that block producers rely on. And so yes, DOS protection is a big part of the Flashbots relay design. I believe we still have kind of this two-tiered API with reputation score. I mean, I think it's like everybody starts in kind of the lowest queue, and it's just like it introduces a very kind of simple form of Sybil resistance where you just have to, I think you just have to make like one bundle or two bundles and land them on chain in order to sort of move to the kind of higher queue. So it's really like a very small kind of form of Sybil resistance. So I think the answer is, I think, just better DOS protection. So Tsui Geo asks, I'm hearing more and more about multi-block MEV. What are some examples of strategies that would exploit this? And is multi-block MEV something that is a bigger issue on ETH2 versus ETH1? So multi-block MEV is when you have MEV that you extract over the course of multiple blocks. So most MEV that we see today is just sort of in and out. It's like inside one block. Very often it is even it is even atomic, so within the same transaction. But if you control multiple blocks, or you can collude with someone and thereby so implicitly control multiple blocks, the question is, what kind of new strategies does this allow you to capture? And we know, so if this number is very high, the available multi-block MEV, that would be quite bad. Why? Because then there would be a big incentive for someone to control all of the stake. Basically, then you get increasing marginal returns for owning more and more stake. And that's something that we genuinely want to try to avoid, because it's, of course, a centralizing force. So I only know of one strategy that where this really is an issue today, and that is attacking TWAP oracles. So for example, there are some exchanges or other systems, lending markets primarily, that rely on Uniswap v3 TWAP oracles. So TWAP oracles is not the price in a particular block, but rather the price over multiple blocks. And if you control more than one block, then you can effectively manipulate TWAP oracles at a very cheap price. So this is indeed a problem for any application that relies on TWAP oracles. And it is much easier to exploit this in proof of stake. Why? Because in proof of stake, who is the next block producer is actually known in advance. So proof of work follows this Poisson process where you don't know who the next miner is going to be. Right? It's just you don't know in advance who's going to find the golden nonce. But in proof of stake, you can see who all of the next epoch is going to be the next block producer. So you know, if you have two blocks in a row, you know it completely reliably. Or if maybe you have a block and then your friend has a block, then you know that you can work together, right? So it makes it very easy to identify any time windows when you control multiple blocks. It takes all of the randomness out. And it also makes it easier to collude. So yes, I would say the answer is multi-block MEV is only basically exploiting TWAP oracles that we know of, at least today. It's not many applications that rely on this, but there are some. So it is a problem. And these applications, they need to move away from TWAP oracles. And it is a much bigger problem in ETH2 than in ETH1, but it's still not a very big problem that we have to be worried about. Next question. So Sam Laff is asking, PBS will use a commit reveal scheme. Block builders only send a hash of the block and a fee to the proposers. How is that different from threshold encryption? So you're right. It's not very different. It is a form. I mean, it doesn't use. It's a commit reveal scheme, but it's not threshold encryption because it's not a multi-party process, right? It's sort of in threshold encryption. I think typically you need multiple parties to work together to decrypt the transaction. So I think this is different here. It's just one party. I think threshold encryption is one variant of a commit reveal scheme that involves sort of multiple people who decrypt it to work together. So I think that is kind of how the two relate. But I'm not super technical. So Yashwant is asking, how should an average coder get into MEV? So I think that, I mean, it's getting harder and harder, frankly, I think, to be a searcher on Ethereum. So, I mean, I think there's a lot of good resources. I think there has actually been a presentation by Brock from Flashbots also earlier. So I would try to watch that for a starting point, and then try to go into a community of searchers that already knows a lot about MEV. And so this is actually, so if I were a searcher, then I could apply a lot of my knowledge from poker, because poker is a lot about table selection. So what this means is you want to find players who are actually worse than you, where you can make money. You don't want to play with players who are only better than you. And this applies very much also in searching. The two are very, very similar in many ways. And in searching, you want to find a market segment where you can have an edge. And so this means maybe finding blockchains where there is not yet a lot of searchers, or focusing on MEV opportunities where there is not yet a lot of competition, because maybe there isn't a lot of money there, but it's enough for you, right? Or it's kind of obscure, like it's MEV that doesn't happen very often. Or it's a blockchain that has maybe a weird kind of ordering mechanism that people have not yet figured out how to break it, or they think it's not clear how to extract the MEV, but it's always possible to extract the MEV somehow. And that's kind of the law, the law of MEV conservation, which is kind of something that I made up. But the MEV doesn't really disappear. You cannot prevent it. It just changes its form, and sort of the act of it will be sort of extracted in other ways. So yeah. So let's see. Post-merge, Seb is asking, post-merge, do you expect builder centralization? So I think builder centralization, yes, it is a big risk for Ethereum, something that Flashbots is very committed to working on. So Flashbots wants to decentralize block building. Centralized block building, very dangerous for many reasons that we mentioned. Biggest reason is exclusive order flow. So if block builders start to pay for order flow, this causes sort of a positive feedback loop where it gets easier and easier to buy more order flow and sort of crowd out other block builders. And also cross-chain MEV, right? So if someone is a block builder on Ethereum and they own a lot of validators on another chain, maybe that does not yet have proposer builder separation, like Ethereum does, then they can capture a lot of MEV that other builders can't. And so there's actually a lot of centralizing forces in the builder market. So it's very important, for one, to try to sort of level the playing field here and make the barriers to entry for new builders as easy and as low as possible. But also we need to build sort of solutions to these problems of exclusive order flow and cross-chain MEV. So we need to make it easier for there to be sort of decentralized solutions that can rival the centralized solutions. So we can have a block builder winning, or multiple block builders winning, that are not centralized and don't sort of have the kind of rent-seeking and censorship potential. And with regards to censorship, I think it would be very important that we also add some techniques, kind of side channels, if you will, or like privacy techniques that even if you have only one block builder, that still make it possible for any user to get any transaction mined. So all of these techniques, I think it will be like a mix of those three techniques that we need in order to combat the threat of centralized block building. Frank Z is asking, any examples of detecting historic cross-chain MEV? So yeah, basically, I mean, when like there's a lot of you can just look at sort of the most active kind of trading accounts on Ethereum, and when they make a single trade, I mean, some they make a trade almost every block, but you know, in this case already, there is probably another leg to the trade here that you're not seeing. Maybe it's on a centralized exchange, right? So maybe they buy something on Uniswap and then they sell it on Coinbase or whatever, right? So really cross-chain MEV is probably the bulk of all MEV that is being extracted. It's just not yet a lot of it is on other blockchains, but a lot is on centralized exchanges. So next question, Pat McCory tweeted this. What do you think? Interesting to see which smart contracts break after the merge. Yes. So, okay, this is the same question about multi-block MEV. So yes, after the merge, it will be much easier to extract multi-block MEV. So this is a good technique here that I forgot to discuss earlier. But yeah, you don't even need to control 2 blocks in a row. All you need is to make 1 block. You can usually get a transaction mined in the previous block and then just put your own transaction on top of your own block that comes after. And so you don't even need multiple blocks. So yeah. Fabaist is asking, I've been thinking about MEV internalization on the protocol level. Any thoughts on this? So, I mean, if you have any, by all means. So this is like the holy grail of sort of designing MEV systems. So Ethereum has sort of a branch of research here that they call MEV smoothing. And the reason that sort of internalizing MEV on the protocol level is very hard is that if you put it in protocol, then you get very big sort of incentives to just for it to move outside the protocol where it cannot be sort of internalized, right? So, for example, via sort of off-chain bribes, right? Off-chain kind of communication. And this is really sort of the big reason why you can't internalize MEV on the protocol level. And there are some techniques you might want to Google for MEV smoothing. You will see, I think, some helpful context there. Do LP aggregators like 1inch reduce arbitrage opportunities? Pedro, yes, they reduce both sandwiching and arbitrage. Why? Because they try to route your trade in a way that gives you a better price. And sort of this has the side effect that they buy from multiple venues. And this is sort of much more efficient, right? And causes no arbitrage opportunities. So that's, or you can think of this as you capturing the arbitrage opportunity that you would have otherwise gotten. So the difference between trading on 1inch and trading on Uniswap, if 1inch gives you a better price, then the difference between the price that you got on 1inch and on Uniswap is actually money that otherwise would have gone to an arbitrageur. So I think that's a very cool, also like conservation. It's another sort of hint at why something like conservation of MEV actually exists, right? And any MEV that an arbitrageur captures can actually be captured by the user just by, you know, making a different transaction. Marcus asks, in scenarios where applications try to internalize MEV and direct it to token holders, is there incentive to lower MEV flipped? Because with high MEV, they can offer low fees while still creating value for token holders. So yes, and this is, oh, so now I see what actually another person asking earlier meant by internalizing MEV. So yeah, I mean, in a way, like MEV is already internalized, right? Because the stakers get it. So that's, I don't know if you meant that or if you meant sort of techniques where the MEV can actually be sort of captured by the protocol in a way that doesn't give it to validators. So I was responding to that question. So I would say yes. I mean, so if token holders make MEV, earn a lot of money from MEV, of course, there's sort of a lower incentive to mitigate this MEV. But I think it depends if you have a kind of short-term versus long-term view on your on blockchain. So is it good to have a blockchain that has consistently higher transaction fees? The answer is in the short term, maybe, but in the long term, no. I mean, a chain that is more expensive to transact surely will sort of all else equal grow slower. And maybe it has just overall less transaction fees in the long term. And so just if DYDX sort of has a lot of MEV, maybe people won't trade there because it's more expensive than other exchanges. And so I think it's a kind of balancing act for these. And I think if you take a long-term view, then it should always be clear that you want to minimize transaction fee for your users as much as possible. And then hopefully, you will become very big and very liquid exchange. And yeah, and then you can make more money that way. Okay, I think we're running a bit out of time. Let's see, what is the most interesting 2 questions? So any plans? How different is MEV in layer 2? So I think the only difference really is today, all layer 2s have a sort of a centralized sequencer. So it's almost like you have Ethereum with only one block builder. Other than that, I mean, they are experimenting with different sort of sequencing techniques. So some of the stuff we already touched on. And so you will have different, the MEV will sort of transform into different shapes and lead to different first and second order effects for users. So that will be very interesting to explore. And then any plans for implementing Flashbots in layer 2? So I would say, yes, we are generally interested. So especially bringing Flashbots to other EVM compatible chains. So, I mean, ultimately, I think that's also was kind of my point too. So we think that like every blockchain should have an MEV auction, because it really is sort of the best way to extract MEV that you can't minimize. It's still compatible with minimizing MEV, right? You can still make transactions private. This reduces front running, but it sort of doesn't change any of the other MEV that exists. Arbitrage, liquidations, back running, all of this still exists in a world where you have private transactions and first come, first serve. So none of these techniques solve MEV. Right? They only solve front running, which is very different. So if you have other MEV, then it would still cause all of these negative second order effects like spam, congestion, and so on. And so, yes, that would be my closing word. So I hope this has been helpful. Thanks for coming.
Yeah, thanks so much, Hasu, for showcasing predictions in MEV for us and answering all of our questions. I know everybody was really appreciative of you staying. Thanks to everybody for kind of staying over and listening to the last couple questions. Just posting a couple more resources here in the chat about previous sessions. If you missed the last one with Robert Miller as well, please check in on it on these pages, as well as you can still register for the hackathon. We also will have another session on Monday with Jolene Dunn, research at Flashbots, same time, same place, Monday the 29th. All of our sessions will be recorded and uploaded to YouTube with our resources. But thanks again for everyone joining. This has been a great start to the workshop series within the MEV Hackathon. Big thank you to Flashbots for putting on all this content and joining us today. And another extra thanks to Hasu for spending 15 more minutes than he was supposed to. So thanks again. Thanks, everyone. We'll see you guys Monday.